In this video, we're going to discuss how a communication between a client and a server is more secure using SSL. We will not be doing any implementation on this video, but rather we'll be focusing on the theory or the architecture behind how SSL works. By the end of this video, you'll gain a complete understanding of how SSL works, and you'll also gain a few knowledge about encryption, such as symmetric encryption and asymmetric encryption. Before jumping right into SSL, there are some core concepts we need to understand in order to understand SSL. So let's look at a very basic scenario. We have a user and we have a server. This can be any servers. Let's just call it a Node.js server. This user will have some data. So this user had some data, and then this user makes certain requests to the server. So let's say that this user makes a GET request with this data, and this data can be any data like authorization headers or access tokens or something like that. So this user makes a GET request to the server and sends this data to the server. The server will process the data and then send a response back to the user. So this is a very basic architecture about a communication between a user and a server. And remember, this user is basically you interacting with the browser. So the browser is actually doing the job of making a request to the server. So we can also call this a client or a browser like Firefox, Google Chrome. But since you are the user, you interact with the browser. For this video, we will just call it a user or a client. So this is the communication that is happening between a client and a server. Can you see a vulnerability in this communication, especially in regards to this data? Whenever this user is sending this data to the server, what can happen is, what happens if there is another person here, another user. This is the hacker. This is the man in the middle. That's in the middle in between the client and server. This is called a man in the middle attack, the man that sits in the middle and tries to sniff this data. So whenever this client sends this data to the server, in this process, the hacker can actually sniff this data and get access to this data. Okay, so this is the vulnerability associated with this architecture. Now, in order to solve this, what can be done? Can you think about it? Of course, we need to find a way to encrypt this data so that the hacker does not have access to the data. So when we talk about encryption, there are mainly two types of encryption. That is symmetric encryption, and we have asymmetric encryption with an A. That's asymmetric encryption. So let's talk about symmetric encryption first. Symmetric encryption is the encryption method where a single key is used both for encrypting the data and decrypting the data. So symmetric key is used to both encrypt the data and decrypt the data. So let's look at symmetric encryption in this architecture. So what this client will do is, this client will generate a key, and this is the symmetric key. Okay, so let's call that a symmetric key. So this client, what this client will do is, this client will use this symmetric key in order to decrypt or in order to encrypt this data. So now this client used that symmetric key in order to encrypt this data. The client uses this symmetric key to encrypt this data, and now this data has become encrypted data. So now when the user sends this data to the server, in this process, this hacker can still sniff this data and get access to this encrypted data. But does the hacker has the symmetric key in order to decrypt this data? No. So since this hacker does not have access to the symmetric key, the hacker does not have access to the content of whatever content this data has. But also there is another problem. Whenever this client sends this data to the server has the data. Now the server has the encrypted data, but again the problem is just like with the hacker. Does the server has this symmetric key that the only client has? Does the server has this symmetric key in order to decrypt this data? No. So that's why this symmetric encryption, it does not work. And because of that, we have another kind of encryption that is called asymmetric encryption. And if you do not know what asymmetric encryption is, it is the encryption method where there are two keys. One is the public key and the other one is the private key. So in asymmetric encryption, we have two keys. So always remember this: public keys are always used to encrypt the data, and private keys are always used to decrypt the data. So in asymmetric encryption, what will happen is, this server here, this Node.js server, will use asymmetric encryption in order to create a public key and a private key. So let's put this encrypted data back to the user for now. So this server will create a public key. Let's call it a server's public key just to make it more clear. Server's public key. And then this server will also have a private key. Server private key. So now the server has used asymmetric encryption in order to create the public key and the private key. So what the server will do next is the server will send its public key. So this public key that's from the server will send its public key to the client. So now the client has the server's public key. What this client will do is the client will use this server's public key, in order to encrypt this symmetric key. So now the user has used the server's public key in order to encrypt this symmetric key. So now this symmetric key becomes an encrypted symmetric key. So next time when the user wants to make a request to the server, what the user will do is the user will first send this encrypted symmetric key to the server. So now the server has this encrypted symmetric key, and remember the server also has the server's this private key, and remember that private key is always used for decryption. So now this symmetric key, since it was encrypted with the server's public key, the server can use this private key in order to decrypt this symmetric key. Okay, so the server will use this private key in order to decrypt this symmetric key. So now this becomes a decrypted symmetric key. So the next time the user sends this encrypted data, and remember this data was encrypted with this symmetric key. This data was encrypted with this symmetric key. So this user will send this encrypted data to the server. So now the server has the decrypted symmetric key. The server also has the private key in order to decrypt that symmetric key. And once the symmetric key is decrypted, the server can use this decrypted symmetric key in order to decrypt this data. So now this becomes decrypted data, and then the server can read whatever the content of that data is. So in this architecture, using asymmetric encryption, it looks like everything is secure, the connection is secure, the hacker does not have access to it, but it's not. There is a major security flaw in this architecture. So let's consider what the vulnerability is first. So let me put this back in place, and this data also right here. So this is all for the user, and this will be encrypted. Let's put this back in place, and this is also encrypted data. So what can happen is whenever this user, or let's put this public key, the server's public key, back in place also. So what can happen is whenever this server is sending this public key to the client, what the hacker can do is hacker can actually take this public key that was sent by the server, and then because hacker can also have public and a private key, right? So let's make that here. So this is the hacker's public key, and then the hacker will also have a private key. So hacker's private key. So what can happen is whenever this server is sending its public key to the client, this hacker can gain access to this server's public key, and then what the hacker will do is instead of sending server's public key to the client, the hacker will send its own public key. So this is the hacker's public key. The hacker will send this public key, his own public key, to the client. So now the client has the hacker's public key. This user does not have any knowledge about whose public key this is. The user or the client thinks that this public key is from the server, but in this case it's not. It's the hacker's public key. So without realizing it's hacker's public key, what the client will do is, just like before, the client will use this hacker's public key in order to encrypt this symmetric key. And whenever this user is sending this encrypted symmetric key, what the hacker will do is the hacker will sniff this or get this encrypted symmetric key, and then the hacker will make a copy of it, and one will be sent to the server, and then one will remain with the hacker. Now what the hacker can do is whenever this client sends this encrypted data to the server, and in this process the hacker will again sniff this and get this encrypted data. So now the hacker will use this encrypted symmetric key, and then the hacker will use his private key, because remember this symmetric key was encrypted with hacker's public key. right? So now the hacker will use this private key in order to decrypt this symmetric key. So now this becomes a decrypted symmetric key. And then using this decrypted symmetric key, the hacker can decrypt this data. So now the hacker has access to that data. So this is the vulnerability associated with this architecture. So in order to solve this, this is where SSL comes into play, okay? Because symmetric and asymmetric encryption was not enough in order to make a communication between a client and a server secure. So that's where SSL comes into play. So now let's finally start discussing about SSL. With SSL, what will happen is we have this server, and usually who generates the SSL? Usually some kind of authority, right? So that can be either ACM or Let's Encrypt, ACM, Amazon Certificate Manager, or Let's Encrypt, or any other authority can generate that SSL certificate. So what will happen is this server here will tell, let's say that it's the authority is Let's Encrypt. So let me put that there. So Let's Encrypt is the authority that will create the certificate. So the server will tell Let's Encrypt, hey, Let's Encrypt, can you make or create a SSL certificate for me? And then Let's Encrypt will say to the server, yes, I can create the SSL certificate for you, but for that I need your public key. So now this server's public key, so where was that? The server's public key, the server will send this public key to this authority, to Let's Encrypt. So now Let's Encrypt has the server's public key, and because Let's Encrypt can also have its own public and private key, right? So this is, so I'll just call it LE for Let's Encrypt public key, and then Let's Encrypt will also have its own private key. So Let's Encrypt's private key. Let's Encrypt is trying to create this certificate. So this certificate will contain server's public key, right? Server public key, and this certificate will also contain the domain name. So for that, let's call it fullstackpro.io. It will also contain some kind of a signature. Remember, this signature is the combination of server's public key. Now Let's Encrypt has access to the server's public key. The signature will contain server's public key, and since Let's Encrypt also has its own public key, the signature is the combination of server plus Let's Encrypt's public key. So now Let's Encrypt has generated an SSL certificate that has the server's public key, domain name, and the signature, which is a combination of server's public key and Let's Encrypt's public key. So what Let's Encrypt will do is Let's Encrypt will send this SSL certificate to the server. So now the server has SSL certificate. So next time, let me remove some of this here. It's very messy in here. Next time, whenever server sends the public key, so this is the server public key. So whenever server sends this public key to the client, the server will also send this SSL certificate that was generated by Let's Encrypt. The server will also send this SSL certificate to the user or the client. So in order to verify whose public key this is, the user does not know if it's server's public key or if this public key is from the hacker. So what the user will do is user will ask Let's Encrypt. So this is Let's Encrypt. User will ask Let's Encrypt for its public key, and then Let's Encrypt will give this user its own public key. So now the user has Let's Encrypt's public key. So now what the user will do is user will take the server's public key, and user will take the Let's Encrypt's public key, and the user will combine those two public key, and the user will check, does this combination, server's public key plus Let's Encrypt's public key, does this combination match this signature? Because remember, this signature is the combination of server's public key and Let's Encrypt's public key. So the user will check, does this combination match? Does this server's public key and Let's Encrypt's public key matches this signature? If it matches, then that public key was indeed from the server. So, but if it does not, let's say that a hacker comes in between, just like before, and if the hacker sends, so that's a hacker's public key, but if the hacker sends this public key, then is this the combination of hacker's public key and Let's Encrypt's public key, is this going to match this signature? No, because this signature contains the server's public key. Okay, so that's why it's not going to match. So this connection is secure, so the user can be rest assured using this signature and this server's public key and the Let's Encrypt public key. The user can be rest assured that the public key was indeed from the server and that the connection is secure. Let's look at a practical example here. So if you go to in this app.eraser.io, if you click on that small icon there, and if you click on connection is secure, not that, yes, right here, if you look at the certificate, then you'll see this public key here. There are other information. So the certificate was issued by Google Trust Services, probably by Google, and then it was issued on, expired on, and it has a certificate code or whatever that is, and it also has this public key. It has the certificate key and it also has the public key. So the user can use this public key in order to create a combination of that signature and decide if that connection is secure, if that public key was indeed from the server and not from the hacker. So that was the architecture behind SSL. I hope you found this video useful. If you did, please don't forget to hit that subscribe button. Thank you for watching, and I will see you in the next one. Ciao.